Hello everyone and welcome to another part of the How to Make a Programming Language series. In the previous video, which I will link in the description, we were implementing parsing our own function definitions. But we never got around to actually calling our own functions. So we were calling our own function here, but nothing happened. So if you go to hello, and we run our hello program on the functions.hello, we found the function definition. So we're actually going to this function call here, or we're actually parsing the function definition here, and the visitor found it basically. Now I got a bit of a headache, but I think we're gonna make this work either way. So the first thing we need to do here is to actually store this function somewhere, because we're parsing it, and then we also need to store it somewhere. So usually what I do here is I just create a scope, like a scope struct, where we can push variable definitions and function definitions too. So for example, this function definition here would be pushed to the global scope. So to do this, we can create a, actually before we do that, I know there's another thing that we forgot to do. So if we're going to the ast.h here, we can see that the members of the function definition here is only the body right now. But we actually forgot to add the function name as well. So we're going to add another member here called char. So this is a string, function definition name. We can call it that. And then in our ast.c, we're just going to make sure that we nullify it. So ast function definition name is equal to void pointer. Okay, and now when we parse the function, we also want to collect that name. So if we go to the parser and we go to the parse function definition, we actually want to put this name here on the AST node. And in this case, we actually want to allocate new memory for it. So what we want to do is basically AST function definition name is equal to calloc, and the length of function name +1, because we want to take care of the null terminator as well, and then size of char. Let's wrap it to multiple lines so that we can see this better. Okay, and then we want to copy function name into this one. So we're going to do string copy ast function definition name function name. Cool. So now if we go to the visitor, maybe we can just print the function name when we encounter the function definition here, just to see that we have successfully parsed the name. So I'm just going to do like that and put node function definition name. And let's compile it and see what happens. We found the function definition do something. Cool. So I think another thing we need to do here is actually add a semicolon here, because right now our source code needs semicolons. So now if we run it again, we're actually parsing this function call here as well. And it says undefined method do something. So it's successfully parsed the definition, and then we encountered the function call, but the function call doesn't know where this function is, because now we actually are going to get into storing this function somewhere. And remember, I told you we were going to store this one, for example, in the global scope. So what we can do here is create a struct. Let's just call it scope.age. And do if not defined scope age, define scope age, and if type def struct scope struct, scope t, and we also want to include ast.age, because this scope here is going to have a list of AST nodes. So we're going to have a AST function definitions, which will be a list like that. And to this list, we will just push function definitions. And then we're going to have a size t function definitions size. Okay, and then we want to have a function to create the scope. So we're going to do a scope t scope init scope. This will just create a scope for us. And I'm just going to have a sip of coffee. Okay, and we're going to have another function here called void. Actually, we can have it return an AST. ASTT scope add function definition scope t. So we need the scope and we need the ASTT function definition. So I think we can start there. So let's just implement these in a scope.c file. So we're going to include /scope.h. So in the init scope, we're simply going to create a new scope. So we're going to do scope t scope is equal to actually calloc 1 size of struct scope struct, and we're going to do scope function definitions is equal to void pointer. So it will be null to start with, and then we're going to have scope function definitions size is equal to 0, and then we're going to return the scope. And in our scope add function definition here, we're simply first going to check actually first we're going to do scope function definitions size plus equals 1. So we're increasing the size here because we're adding a new scope here basically, or we're adding a new function definition to the list. So this variable is just to keep track of how big this list is. And then we want to do if scope function definitions is equal to void pointer. Then we want to allocate some memory here. So scope function definitions is equal to calloc 1 size of struct AST struct. Pointer, it's very important. It needs to be pointer like this because it's going to contain a list of AST pointers. Okay. Otherwise, if it's not a void, if the function definitions is not a void pointer, then we're going to reallocate the memory to fit in one more element. So scope function definitions is equal to realloc scope function definitions. Let's wrap this to multiple lines. And then we want to have scope function definitions size times size of struct AST struct. Right. And then, okay, so what are we doing here is we're increasing the size. We're allocating memory for one element in the list if the element is a void pointer. Otherwise, if the function definition is not a void pointer, we're just reallocating it to fit one more item. And then we want to do scope. Now we actually want to add this function definition to the list. So we're going to do scope function definitions scope function definitions size -1 is equal to fdef. So we're adding it to the end of the list here. And then we can return fdef. Okay, so let's see if it compiles. And yeah, it's compiling. Let's do a make clean just to be sure. Make. Yep, we're compiling. Good. So now we actually want to make use of this scope here. So what I usually do is that I keep that scope in the parser, the global scope, basically. So what we can do here is have the parser, when we first call the parse here, we want to also have a scope argument, scope t scope. And actually we can, let's not put it there, let's put it in the struct of the parser. So scope t scope, and this will be the global scope, okay? And now in our parser.c, in our init method, we want to initialize this scope. So parser scope is equal to init scope. And of course we need to include scope as well. So include /scope.h. Cool. Now what we want to do is basically in all the parsing methods here, in every parse method, we need to also add this this scope argument. And this is because when we are recursively parsing nodes, we're also going to attach scope pointers to the nodes so that we know which scope these functions exist in, or these AST nodes exist in. Sorry. So for our parse method here, we're going to add the scope t scope parameter. And let's see if we can do this quickly to all the methods. Sorry. Scope t scope. There we go. Now we also need to do it inside here in the parser.c. So when we parse, unfortunately I think it's going to be difficult to add it to all the arguments here automatically. So scope t scope, we're just going to copy this. Like so. Scroll down. Parse ID. Okay, now we have added it to all the function definitions. So now let's just see what compiler errors we get here. So make clean make, and we can see we're getting a bunch of errors. So first of all, the parser doesn't know what a scope is. So we need to include scope here in the parser.h, because we're using the scope here in this struct. And let's do this so we can see the new errors better. So now in our parser.c, we're missing to add these arguments to the function calls. So for example, if we start from the bottom, we also need to pass in the scope when we're calling a parser function. So whenever we're calling a parser function, we also need to pass in the scope. I think we're good there. Parse expression. Parse expression. Parse ID. Scope. Scope. Here we have a parse statement. Scope. Scope. Parse ID, scope, scope, and I think that's it. So if we recompile again, we're getting one error, and it's in main.c. So the parser here needs to, the parse function here needs to have a scope here as well. So we can actually just do parser scope, because the parser has a global scope. So we're just passing in the global scope there. Now if we compile, it compiles fine. Now another thing we need to do is actually store the scope on the AST node here. So to do that, we cannot include scope here, because scope is including AST, so that would end up in a circle or include. But what we can do is use this struct, scope struct. We can copy that, and let's just put it here. Scope, like that. Now if we make clean, we now have a scope pointer here on the AST node. So now in our AST.c, let's just make sure that it's a void pointer to start with. So scope is equal to void 0. Okay. Now, in our parser, we want a way to safely get this scope from a node. So what I'm going to do, I'm just going to add a simple helper method here called static scope t get node scope AST node, and we're just going to do, and actually we need to pass in the parser here as well. So parser t parser. Then we're going to do return node scope is equal to void pointer. So if it's a void pointer, then we're going to return the global scope. So parser scope. Otherwise, we're going to return the node scope. Okay. So now what we want to do is, while parsing, we want to attach the scope to the nodes, basically. So what we want to do in our parser parse statements here, for example, we're parsing a identifier. So then we're going to end up in the parse ID, and that is going to parse some variable definitions, function definitions, and things like that. So whenever we're creating a new node, we also want to put the scope on it. So here, for example, we're parsing a string. So before we return the string, we're going to do AST string scope is equal to scope. Okay. And in our parse variable, before we return the variable, we're going to do AST variable scope is equal to scope. And in our parse function definition, we want to do AST scope is equal to scope before we return it. And in our variable definition here, we also want to do the same. So variable definition scope is equal to scope. And then we have function call. So function call scope is equal to scope. And I think that's it for now. Just to be sure, we also want to put the scope here on the AST statement and the compound. So let's also do in our parse statements, when we get an AST statement here, we also want to do AST statement scope is equal to scope. And in our when we create a compound, we also want to do compound scope is equal to scope. Cool. Cool. So I think we got the scope all figured out. Pretty sure we did that. Good. So now in our visitor, when we encounter the function definition, we want to add that function definition to the scope where the function definition exists. So to do that, we can simply do, we added this function scope add function definition, and we want to do scope, node scope. So we want to add it to, let's just move my camera a bit so we can see this better. So we want to add the function definition to the function definition's scope, which will be the global scope in this case. So we're just going to add the node to the node scope, basically. Okay. So scope add function definition, scope node. So we're adding that scope to, or we're adding this node to the scope, basically. So now if we recompile, we get some errors here. Because we also need to include the scope here in the visitor. There we go. So let's just see if we can run this now without errors. Cool. So we're just getting undefined method do something. It didn't crash or anything, so that's good. So now in our function call, we just need to look up this function, okay? So what we can do here is basically, we need a function to get another function, or we need a function in the scope to get a function definition, basically. So let's just add another function to our scope.h here. Let's call it ASTT scope get function definition. And we'll have the scope as the first parameter and a function name as the second parameter. Now let's add it to scope.c. And let's go ahead and implement it. So now what we need to do is just iterate through all the function definitions and compare the names to find the correct one. So for int I is equal to 0, if I is less than scope function definitions size I++, and then we're going to fetch the current function definition in there. So AST fdef is equal to scope function definitions I. And then we're going to do if string compare function definition name, and we're going to compare it to this name that has been passed into the function. If they are the same, then we're going to return fdef, And at the end of the function, we're just going to return void if we didn't find something, a void pointer. So does it compile? No, we need to include string.h to make the string comparison. And it's time for another sip of coffee. Okay, now in our visitor, we're just going to make use of this function inside our function call. So in our program here, when we're encountering this function call, we're going to do a lookup for this function definition here and see if it's in the scope. So what we can do is ASTT fdef is equal to scope get function definition, and we want to fetch the node inside the node scope, so the same scope as the function call, and then we need the name of the function. So it's actually node function call name. Okay. So now we can do if fdef not equals to void. So if we found a function definition, we're just going to print found it, just to see if it works. So compile, run our program again, and as we can see, it found the function definition. So now we actually want to call the function. So how do we do that? Well, the function definition here has a body, which is a compound. So if we go into the parser, we can see that when we're parsing the function definition, we're parsing a statement list here, which is a compound, and we're attaching it to the function definition body. So all we have to do is visit the body of that function definition. So in our visitor here now, we just need to do, return visitor visit visitor and fdef function definition body. So if we found the function definition, we're going to visit the body. Okay, so let's try that out. Make, and now we can see it called our function. So let's just do print, this is our function calling. And if we run it, we can see that we successfully called our function. So let's try and call it multiple times. Cool, right? Now, what if we call a function that doesn't exist? Yo. We're getting an undefined method, yo. So that's good. We can remove these extra braces here, they're not needed. And by the way, we actually wrote a function that we didn't use here. So in our parser.c, I wrote this get node scope function. It seems to me that we're not really using it, so I'm just going to remove it. There we go. Cool, so now we can call our own defined functions. And as always, I put the source code in the description, and hopefully in the next video we can look at how we can make it possible to accept function called arguments. So if you want to see that video, please like this video, and if you're not already a subscriber, please hit the subscribe button, and I'll see you in the next video.